So in this video we're going to start factoring, and factoring is literally just the opposite of multiplying things together. For example, with numbers, like a number like 6, its factors are 2 and 3 because 2 times 3 gives you 6. They multiply together to give you 6, so those are the factors. 1 and 6 are also factors of 6. They're not very exciting factors, but they are factors. What we're going to be doing is looking at expressions. So if you have something like x squared plus 36, how could I split it into like 2 different things that multiply together to give me this? To start off with, and we're going to break this into sections. And if you want to make like a graphic organizer on a piece of paper, I think that would be helpful, where like we're going to look at 2 term stuff separately, 3 term stuff separately, and 4 term stuff separately. But regardless of however many terms the expression has, when you're factoring, the first thing you should always look for is, does it have a GCF, a greatest common factor? If it does, you want to factor that out first. We've already covered this, but I wanted to go ahead and review it just a little bit. Again, just as a reminder, factoring is the opposite of basically multiplying something out. So like if I had this expression right here, and I wanted to distribute the 2, that would give me 2y plus 6. These expressions are equivalent to each other. They're the same thing. So factoring is like going backwards. It's like saying, oh look, I could divide both of those by a 2, and so you bring that 2 out to the front, and then if I divide that by 2, all that's left is a y, and if I divide this by 2, all that's left is a 3, and so this is the factored version of this expression. Sometimes we call it expanding or multiplying it out. So the 2 is the GCF. It's the greatest common factor. It's a factor of both of these because it divides in evenly. It's the greatest amount of stuff possible that they have in common. So the greatest common factor. You put that GCF up front, that's the GCF, and then in parentheses write down what you have left, and it's equivalent to that expression there. If you want to check your work, just distribute and make sure it does get you back there. Note that 2 and y plus 3 are factors of this expression because I can multiply them together to get this expression. There's a few more examples on the paper that I have given you about factoring with GCFs. Just wanted to show you a few of those. Like for example, on this one, see how they all divide evenly by 10? That's the greatest number that I can divide them all evenly by. This one doesn't have any variables, so you can't factor out any variables for the GCF. So I put that 10 up front and then write down what I have left after I divide each of these by 10. That's going to leave 2x to the 4th here, negative 3x here, and positive 3. Here's a more complicated example. This one has a 3 and this one has a 7. So the only number I could divide them evenly by would be a 1, and I don't really need to write a 1 down. Note that this one has 2 x's and this one has 5 x's. So the most I could take out would be 2 x's and x squared. And this one has 5 y's and this one has 3 y's, so the most y's I could take out would be y cubed, which would leave, and this one I have a 3 left over. I took out both x squareds and I took out 3 of the y's, leaving 2 left. On this one, the 7 is still there. I had 5 x's and I took out 2 of them, so I've got x cubed left. And I had 3 y's, I took out all 3 y's, there are no y's left. So that's how this turns into this. So I'll let you look through the rest of those and then do the practice.